Okay. Hello, kids. Today I'll be talking about a classical piece of French machinery that is near and dear to the hearts of many. The guillotine. Now you see, the guillotine was used for executions in France from 1792 to 1977. That's about 185 years. Wow. The guillotine was put into place by Joseph Ignace Guillotine, for the purpose of making a more humane and painless execution experience. To operate the guillotine, one must pull the rope attached to the weighted blade and have someone else lay belly down on the bascule of the guillotine and then put their head in the brace of the guillotine and then brace for their execution. To visualize the forces of these actions, one must look at these diagrams of the forces. To find out the forces, you gotta look at the forces diagram. What do you think it would be? What else diagram could it be? It's the forces diagram. Anyways, as you can see, this force diagram is after we've pulled up the rope attached to the weighted blade, but before we've let go of the rope and let the blade come down. This is why the tension force is applied to the top of it, which is preventing it from falling due to the gravitational force of the Earth pulling it downward. The second diagram represents when the blade is dropped. This is mid-dropping because it has not hit the neck of the person who is being executed. As you can see, the air resistance is fighting against the gravitational force of the Earth, but is not enough to stop its acceleration towards the neck of the person. Here are some of the ways the guillotine represents some of Newton's laws. Firstly, it represents inertia because when the guillotine is not in use, it's like if no force is applied to the guillotine, then like it's not gonna do anything. When you're not using the guillotine to do executions and stuff, it's not doing anything. The way Newton's second law is exampled by the guillotine is because you see the blade is actually weighted. So the weight times acceleration is the force. So the reason it is weighted is so the guillotine has enough force when coming down the neck to chop it off. That's science. Now, the way the guillotine demonstrates the third law is because when the blade comes down upon the neck, the blade and the neck feel the same force. But the reason the blade doesn't break and the neck doesn't is because of the previous state, the blade's weighted. It's thick. It's made of a very sturdy material, iron, and your neck is not made of iron. But it also has to be strong enough, because if the blade was like, let's say, weak aluminum, it would snap in half on the neck, because the neck is actually pretty strong. It's bone, bone. You can't crack bone and that's a lie. You can crack bone pretty easy. Look at this. So yeah. That's why they weight the blade. They need to weight the blade. I lost the plot. Let's talk about the force relation. When I said the force relation, I really just meant the relationships between some of the different elements of the guillotine's operation. So let's discuss one of them: the relationship between its force and its mass. You see, as stated previously, the blade is weighted because mass times acceleration equals force. So the more mass the blade has, the more force it will come down upon the neck with. Now let's talk about the relationship between mass and acceleration. You see, mass and acceleration, I think I've said this before. Like, to be honest, I explain things out of order sometimes. No, not out of order, it's just like everything relates to everything in physics. I don't know physics. I don't know enough about physics to say that for sure. Anyways, so, mass acceleration. Now, the acceleration of the guillotine is, constant usually, because it's the gravitational force. That's what the blade is using to come down. It's using gravity. It's not using any other force. There's no springs in the guillotine. No funny springs. I made the first spring-powered guillotine. No, we're not doing any of that. And the only thing that changes is really the mass. So it's the mass times the acceleration gives it its force. So, yeah. Alright, now we're talking about the relationship between acceleration and gravitational force. Well, you see, it's the same thing, Because in this case, it's the guillotine's blade coming down is just the acceleration of gravitational force. So it really only depends on the planet the guillotine is placed on.